So we are going to continue solving these equations. We have done lots of exponential equations at this point. We did them on our test. The last test we took on the quiz, you had log equations that we changed into an exponential and solved. But all of those we solved by getting a common base. And sometimes it's not possible to get a common base because not everything works out perfectly. So we need another option. We are going to use these two properties. Today we're focusing on the first one. We're going to be taking exponential equations. And so it turns out if two things are equal, you can add a log to each side and they'll still be equal. Tomorrow we'll focus on the reverse. If both sides have a log, you could take that log away on both. We do this if a common base is not an option. So if I ask you to solve 8 to the x power equals 21. All right, I could rewrite 8 as 2 to the third, but can you do 2 to some power to equal 21? No. So what we're going to do is add a log on each side. Now technically you could do whatever base you like. I prefer doing just log base 10 or natural log because those are the two buttons we have on our calculator. And so if I want to get decimals, it's nice if we can plug them in the calculator. Now the reason I do this is because properties of logs, what's going to happen with my exponent?
Equals 5.
Remember, it turns into a coefficient. So we were doing that on our quiz, just expanding and condensing. So the exponent comes down. So now you have x times log 8 divided by log 21. Opposite of multiplying is?
Dividing.
So we divide our log 8 over. And my answer is log 21 over log 8. This is called the exact answer. You're going to do, the homework tonight is Math Excel, and sometimes it asks you for the exact answer and sometimes it asks you for the approximation. Exact answer still has logs in it. The approximation is the decimal we would get if you divided them out. So, on your calculator, when you push the log button, it opens a parenthesis, so make sure you close it. And I do want everybody to type these in so we can make sure we're getting the same thing. In general, I usually go 3 to 4 decimal places on these. I think the Math Excel asks for 3 decimals on the assignment today. So 1.464 or 0.4641 if you went 4 decimals. As far as checking these, you can plug them in. If you type 8 to the 1.464 power, it doesn't turn out to be exactly 21, it's 20.995. Why is it not exact? Yeah, that's our approximate. We rounded that. The more decimal places you have, the closer it gets to 21. But that's a pretty good check. If you plug it in, you can make sure it's close to 21. Why don't you guys try this one? 3 to the 2x equals 1.4. So you can't get a common base, you add your log. This one does have one more thing. Our exponent isn't just x, it's 2x. So we put a log on each side, then the entire exponent, 2x, comes down in front. So x is multiplied with both the 2 and the log 3, so you are actually going to divide both of them. So we have log 1.4 divided by 2 log 3. That is my exact answer. To put this in the calculator, you do have to be a little bit careful. When you push log, it opens a parenthesis, you have to close it. And then you need parentheses around the entire denominator, or you need to enter it as a fraction where you can view the fraction and make sure you have the correct things on numerator and denominator. So if anyone's having trouble putting that in, please let me know so I can help you. So you have to put an extra set of parentheses around that 2 log 3. So our approximation is 0.153 if we plug that in. Anybody need me to look at their calculators? Let's look at this one. So we have to make sure the exponential term is isolated. We don't want to make our problem get more complicated than it already is. And so if you try to add your log too soon, it's going to make our problem uglier. When I look at this, I see I have 2 different exponentials. Before I add my log, I'd like to combine those into one. If you're multiplying, what do you do with the exponents? So x plus 1 plus 3x would be e to the 4x plus 1. So now we need to add a log. You can add the same log we have been on the past 2, but I actually like, if I have e's, I like to use natural log. You don't have to, you'll get the same answer. It's just a little bit faster because if you remember, natural log means log base e. What happens if you have a natural log of e? Yeah, those just cancel each other out. So it gives us a nicer expression to deal with. So again, you can do it either way. I use natural logs every time I have an e. Then if I'm trying to get x by itself, what would we do? So this is the natural log of 4. That one is just on the end. And then we have to divide by 4. So we have the natural log of 4 minus 1 all over 4. If you're putting that in your calculator, you need parentheses around the numerator and after your log. What did you guys get?
0.096 or 0.097.
Questions? Want to make sure everybody's getting these on their calculators. You are these all good on your plug-in? Come in. Let's start here. Do you just want one page or just the first page? Let's take a look at this. We want to isolate the log, or sorry, the exponential, before we add our log. So the exponential, that's the thing with the exponent on it. So what would I do first? I have to get that e part by itself.
3 times ln of e 5x.
Yeah, I have to get the e by itself because when I add the natural log, I have to do the entire side. So it's 3e to the 5x equals 7. Okay, the e to the 5x, that's the thing with the exponent, so I'm still trying to get that by itself. So the opposite of multiplying by 3, divide by 3. when you have a natural log and an e, they can cancel. If you don't, if you keep that natural log e, it's fine. You'll just bring down your 5x and divide it over. But if you recognize that shortcut, because natural log of b is 1, that would just go away. So we have 5x equals the natural log of 7/3. So then if I want x by itself, we just have to divide by 5. We have the natural log of 7/3 divided by 5. And that should give me approximately 0.169. Why don't you guys try the next one? Do example 5. If you get that one done, you're still a little bit different. I wanted everybody to try problem 5. We have to isolate the exponential, the thing with the exponent. That is my 3 to the x. So I need the 3 to the x on the side by itself.
Divide by 5.
So we start off dividing our 5 over. 3 to the x equals 6 fifths. Now, it doesn't have e, so we don't need a natural log, but it's kind of like example 1. We can add our log on each side. When you do that, the benefit is exponents come down in front. So we get x log 3
Divide by log 3.
X is log of 6 fifths divided by log 3. And you're welcome to put parentheses around those if you want. On your decimal,
0.166.
did we get that one? Example 6 is a little bit uglier, but the process doesn't change. I need the exponential, the thing with an exponent by itself. So what would we do first? So we get 4 times 2 to the x plus 3 power equals 80. Then what would we do? So 2 to the x plus 3 equals 20. At this point, can we get a common base between 2 and 20? 2 to a power doesn't equal 20. So that means we have to
Log
add logs. So we put 1 log on each side.
Move the x plus 3 in front of the log.
Exponents come down. My entire exponent is x plus 3. So that all comes down. So x plus 3 times log 2. At this point, I'm trying to get x by itself. So what would I do with this log 2?
Divide it over. And then subtract 3.
So x plus 3
Equals log of 20 over log 2. And subtract 3 over.
so x equals log 20 divided by log 2. And the minus 3 is just on there.
And then it should be 1.322.
So it's solving an equation, but you have to remember first get the exponential by itself. Then you add your logs and try to get x by itself. What questions do you guys have so far? I'd like to do 2 more examples and that's where I'm stopping for today. So these next 2 examples, you'll notice there's a little more algebra that will be involved because when you look at the problem, how many x's do we have?
2.
2. We have more x's. But the process doesn't change. Okay, we want to isolate the exponential. Well, for us now, there's one exponential on each side. So we're going to just go straight into adding our log. So we put a log on each side. And then once you have logs, what's the thing we always do next? Both exponents come down. So I have 2x log 5 equals x plus 1 times log 8. I put that x plus 1 in parentheses because that's all getting multiplied with my log 8. Now here's where it's different from the last problem. I have multiple x's. I have to be able to get those on the same side. For me to do that, I'm first going to have to multiply out the right-hand side. Now, log 8 just represents a number. So when you multiply anything with it, it just goes in front of the log. So x times log 8 is just x log 8. 1 times log 8 is log 8. What did I do now? We need the terms with the x on the same side. So what I'm going to do is subtract over this x log 8. Now, they're not like terms, so I can't actually combine them because the logs are different. So I just have 2x log 5 minus x log 8 equals log 8. But we're really only 2 steps from the answer. Both of these have an x. I can't subtract them, but what I can do is factor out the x. If they both have it, you could take it out.
Divide 2 log of 5 minus log of 8 by log of 8.
You have x times all of this stuff. The opposite of multiplying is dividing. So all of that goes in my denominator. You have multiple terms on the bottom, so you can't cancel them because of the subtraction. Now, if you are putting that one in your calculator, you will have to be a little bit careful. You have the log 8 divided by, then you need another set of parentheses. 2 log 5 minus log 8. So since the bottom has 2 terms, you need a set of parentheses around the whole thing. Or type it in where you can view the fraction and make sure you get the right things on the bottom. Is that one okay? Try the next one. So we add the log on each side. Yeah, and some of you are going ahead and dropping down your exponent when you do that, which is totally fine.
To distribute the log with the 1 minus 2x.
1 times log 3 is log 3.
Minus 2x log 3.
this on the same side. So we can add over the 2x log 3. Now, unfortunately, these logs aren't like terms, so I can't combine them, but they both have an x, so what do you do?
Take out the x.
And so then final step to get x by itself is 2 to, so we have log 3 over log 4 plus 2 log 3. Did you guys get that?
And it should be 0.307.
If you had all the signs opposite, that just means you moved everything to the other side, and that is also correct. Get 0.307. Okay. There is a math Excel assignment open, and we have time to work and ask questions right now.